Hello students, welcome back to our channel. Students, in this video we will discuss chapter 8 from class 12 mathematics, and this is applications of integrals. Using the concept of integration, we will find the area of the figures bounded by some curves. For example, let us say this is y-axis and this is x-axis, right? On y-axis, suppose we have plotted a function fx, with respect to x, and this function, the graph of this function, suppose looks like this. Okay, now suppose I have to find the area bounded by this function from A to B, right? Area of this function bounded by the graph, area bounded by the graph of this function from A to B, which means I am supposed to find this whole area, right? Let me make it darker for you. Suppose we are supposed to find this area, right, which is the area from A to B bounded by the graph of this function. So in such cases we can use integration. We know that we can easily find the area of the figure if it has some symmetric shape. For example, we know how to find the area of rectangle, we know how to find the area of triangle or circle, but this is not a symmetric shape, this is not a shape which is known to us, this is an irregular shape. So to find the area bounded by the irregular shapes, we use the concept of definite integration. So how we are going to find this area? This function fx, this fx will be a function in x, right? So what you will do, you will make this integral, you will make lower limit a and upper limit as b, that is a and b are those two values between which this area is lying. So a becomes the lower limit and b becomes the upper limit, and here you will write the function fx and dx. So this is going to be the required area, right? This is going to be the required area. So we have to solve this integral. We will take 2-3 examples and you will get to know the concept deeply, but let me first show you how is it coming, why this area is the integral of fx dx. Suppose we have very small areas, we have divided this whole areas into very small rectangles, right? I have made this a bit broader so that you can easily see, but you just have to imagine that we have divided this whole area into rectangular strips of very small size. The thickness, the width of this strip is very small, right? So you can imagine that this width is very small. You can imagine that we have divided this whole area into almost infinite such strips, because this strip is very thin, right? And let us say the width of this width of this strip is dx, right? Width of this strip is dx. Let me use some other color for this. Width of this strip is dx, right? And since this width is very small, so whatever be the shape of this curve, if this is very small, we can take this as a straight line. So we can say that any one of these infinite strips is in the shape of a rectangle. So the total area is simply the sum of the areas of these small rectangles. And what is the area of a rectangle? Area of rectangle is length into breadth. and the breadth of this strip is dx. What is the length of this strip? Length of this strip is this, and this is nothing but fx, because fx is in y-axis, so fx will represent the height of this strip, or we can say the length of this strip. So the area of one strip is fx dx. So what is the meaning of integration? Integration is used when we have to add all these small parts together. So if I want to add the area of all the strips from A to B, I will simply integrate this fx dx from A to B. So that will be the required area, right? Now let us take one example from NCERT exercise 8.1. Find the area of the region bounded by this parabola. Find the area of the region bounded by this parabola y square equal to 9x and line x equal to 2 and x equal to 4 and the x-axis in first quadrant. So let us first draw all these figures to solve the questions of this exercise or this chapter. You must know that how to draw these simple figures like parabola, circle, and ellipse and straight line. Straight line you all know how to draw because you have drawn straight lines in class 9th, in 10th, in 11th. But in class 11 there was a chapter called conic sections, and in conic sections you studied how to plot the graphs of parabola, ellipse, and circle. So if you do not remember that chapter, first you have to revise that chapter and you first learn how to draw the graphs of these figures. Only then you can come to this chapter and solve these questions. Otherwise you, if in this question it is given that you have to find the area bounded by this curve and you do not know how to draw the graph of this curve, so you won't be able to even start this question, right? So you first have to revise that chapter so that you become familiar with drawing all those figures. So the shape of the parabola whose equation is y square equal to 9x is this, right? And this is our x-axis and this is our y-axis. So this is y square equal to 9x. Okay. Second is the line x equal to 2. So x equal to 2 line is this. This is 2, suppose. So this is the line x equal to 2. X equal to 2. And the third is the line x equal to 4. So this is the line x equal to 4. And we are supposed to find the area bounded by this parabola, this line, and the x-axis. So which one is the required area? This is the required area. This is the area which is bounded by x equal to 2, x equal to 4, parabola and the x-axis. So we are supposed to find this area. So this point is x equal to 2 and this point is x equal to 4 and this is fx, and we all know that fx is equal to y. We know that y is nothing but fx because on y-axis we have plotted fx. So we can say that y is equal to fx. So that means if we are applying this formula a to b fx dx, so we simply have to take the y of this curve, right? Because y is equal to fx. So we have to take the y of this curve. The y of this curve is under root 9x, right? Y of this curve is under root 9x. So the required area is 2 to 4 under root 9x dx, right? Because y was under root 9x. So what is the area? So what is the area? Area is 2 to 4, root of 9 is 3. So 3 is taken outside and this is root of x, that means x to the power 1 by 2. Now let's integrate this. So it becomes x to the power 1 by 2 plus 1 upon x to the power 1 by 2 plus 1 from 2 to 4, right? Now solve it. 1 by 2 plus 1 is 3 by 2. 3 and 3 are cancelled. Okay, I'll write one more step. So this is x to the power 3 by 2 and this is 3 by 2 whole limit 2 to 4. Now 3 into 2 by 3, because when it comes to numerator it becomes 2 by 3, and in place of x first we will put the upper limit, then we will put the lower limit. 3 gets cancelled and this is 2. 4 is the square of 2, so we can write it 2 raised to power 2 minus 2 raised to power 3 by 2 means first you take the cube of 2 which is 8, then take the square root of 8 which is 2 root 2. So we can write it 2 root 2 and this is 8. So 2 bracket mein 8 minus 2 root 2. So this is 16 minus 4 root 2, right? And since this is area, so you will write this, and with this you will write square units, because area is always in square units, whether it is meter square, centimeter square, millimeter square or anything else, but it is always in square unit, right? Okay, now let us take one more example from NCERT. Find the area bounded by the curves x square equal to 4y and the line x equal to 4y minus 2. X square equal to 4y is this parabola. X square equal to 4y is this parabola, right? And the line x equal to 4y minus 2. So to draw this line, let us take 2 points on this line. When you put x equal to 0 in this line, you will get the value of y. So the value of y is 2 by 4, which is 1 by 2. And when you put y equal to 0 in this line, you will get the value of x, which is minus 2. So there are 2 points lying on this line. First point is 0 comma 1 by 2 and second point is minus 2 comma 0. So 0 comma 1 by 2, x0, y1 by 2, it lies somewhere around here, and x is minus 2 and y0, it lies somewhere around here. So let's draw a line passing through these 2 points, which is suppose this. Okay, we will just shift the position of this point according to our convenience, and this is the point. Let us mark this with yellow. This point is 0 comma 1 by 2, right? This point is 0 comma 1 by 2 and this point is minus 2 comma 0. Now we are supposed to find the area bounded by the curve and the line. So where is the area bounded by the curve and the line? This is the area which is bounded by line and curve. So what are the limits? Now listen carefully, that from this point, this area lies from this point to this point, right? From this point. Okay, from this to this. So first we have to find these points. What are these points? These points are the points of the intersection of this line and parabola. So to find the points of intersection of line and parabola, what we will do, we will put the value of suppose what? We have to find the x coordinate. So let's eliminate y. What is the value of y? Solve this and you will get, find the value of y from this. The value of y from this is coming out to be x plus 2 divided by 4. Now if we put, because this point and this point, these are the 2 points which lie both on line and the parabola. So if we substitute the value of y in this, we are getting a quadratic equation, and Let's solve this quadratic equation by splitting the middle term. So the value of comes out to be -1 and 2, and obviously the -1 value is this. So this point is -1 comma 0 and this point is 2 comma 0. So simply we will find the area from -1 to 2, right? We will find the area from -1 to 2. So if I put the y of line from -1 to 2, then I am going to get this whole area, right? This whole area. But I do not need this part. So what I will do, I will subtract the y of parabola from this, because the y of parabola will give me this area according to the concept, right? So if I'll subtract the y of parabola from y of line from -1 to 2, I'll get the required area. So what is the y of line? Y of line is x plus 2 by 4, right? Let's write it on the next page. So required area is -1 to 2, -1 to 2, y of line is x plus 2 by 4, x plus 2 by 4 dx minus -1 to 2 y of parabola. What is y of parabola? Y of parabola is x square by 4. Y of parabola is x square by 4. So we just have to solve this integral. So 1 by 4 is outside the integral sign. So integration of this is x square plus 2 plus x square by 2 plus 2x, limit -1 to 2 minus 1 by 4 x cube by 3, limit -1 to 2, which is 4 by 2. First I'll put 2 minus, then I'll put -1. So -1 ka square by 2 is 1 by 2 minus 2 minus 1 by 4. First I'll put 2, so it is 8 by 3, then I'll put -1, so this is -1 by 3. So 1 by 4, 2 plus 4 is 6, minus plus 3 by 2, minus 8 minus 1 is 7 by 3. So 7 by 4 into 3, 12. So finally it is 1 by 4, 2, 12 plus 3, 15, minus 7 by 12. So this is 15 by 8 minus 7 by 12. 15 by 8 minus 7 by 12. LCM of 12 and 8 is 24. So it is 45 minus 14. 45 minus 14 is 31 by 24 square unit, right? 31 by 24 square units, right? So this is how you can solve. Now let's take one more example. In both the examples that we have discussed till now, there was a curve and a straight line or more than one straight line. But in this example, we have two curves, right? And both are parabolas. So what we are supposed to find? We are supposed to find the area of the region bounded by these two parabola. So first parabola is y equal to x square, which is this, and second parabola is x equal to y square, which is this, right? So we have to find the area bounded by these parabolas, which is this area, right? So how we are going to find this area? First, let us find this point. Let us find this point first. This point will be the point of intersection of these two parabolas. So if we put the value of y as x square or the value of x as y square in any of the parabolas, na? So first is y equal to x square and second is y square equal to x. So now we have to find x, so we have to eliminate y. What is the value of y? Value of y from here, value of y is root x. So this is our equation. Squaring both sides, we get x equal to x to the power 4 or x to the power 4 minus x is 0 or x cube minus 1 equal to 0. So one point is 0 where these parabolas are meeting, and that we already know, but we have to find the other point, right? So x cube is 1 or x equal to 1. So this point is, the x coordinate of this point is 1 comma 0. So if we integrate it from 0 to 1, if we integrate it from 0 to 1, and first let us put the y of this upar wala parabola. Y of this parabola, this parabola is this one, and y of this is root x. Y of this is root x. So this integral will give us this whole area, but we do not need this area. So let us subtract the area bounded by this parabola, which is this, and y of this is x square. So minus x square dx from 0 to 1, right? Okay, so what is the value of this? X to the power 1 by 2, and the integral is x to the power this from 0 to 1 minus x cube by 3 from 0 to 1. So if let's put 1, so putting 1 we get 2 by 3, 0 se kuch nahi mila, minus 1 by 3, which is 1 by 3 square unit. So that is the area bounded between these two curves, right? So this is how you can solve all the questions of chapter 8 from class 12 math. So go and solve those questions. I'll meet you in the next lecture. All the best.